Now that we've introduced the limit laws, I'd like to demonstrate how to actually make use of them as we evaluate the following limit. This is going to be the limit as x approaches 3 of the square root of 3x plus 7 all over x squared plus 16. Now I mentioned in the last video the way that you start this process is by saying if I were given this expression, what would be the last thing that I would do according to the order of operations? Well, according to the order of operations, first I'd take care of the exponent that's down here, and then the multiplication, and then the addition that takes place in the numerator and denominator. Then I would divide, and the very last thing that I would do is apply the square root, since it applies to the entire fraction. So the first thing that I'm going to do is apply the root limit law that says that I can move the root to the outside and move the limit to the inside. So this will now be the limit as x approaches 3 of 3x plus 7 over x squared plus 16, all under a radical. Now my limit is of this expression, and according to the order of operations, the last thing that I would do to simplify this expression would be to divide. I would simplify the numerator and simplify the denominator and then divide. So I'm going to apply the quotient law. So we'll still have a nice big radical. We'll still have a nice big fraction, but now we'll be taking the limit as x approaches 3 of the numerator divided by the limit as x approaches 3 of the denominator. That's x squared plus 16. So now we've split our one limit into two limits. Now for 3x plus 7, the last thing that I would do according to the order of operations would be to add. So in the numerator, I'm going to be making use of the sum rule. Same thing goes for the denominator. Square the x and then add the 16. We'll be using the sum rule for the denominator as well. So now we'll have the square root of, nice big fraction. In the numerator, we'll see the limit as x approaches 3 of 3x plus the limit as x approaches 3 of 7. In our denominator, we will have the limit as x approaches 3 of x squared plus the limit as x approaches 3 of 16. Now I'd like to continue to simplify our limits before we actually start using our evaluation limits. So in the numerator, I would like to make use of the fact that this is a constant times x and use the constant multiple limit law. In the denominator, we have x raised to a power. Because it's x raised to a power, I'm going to use the power law. The way that that manipulates things is the following. I feel like this radical just keeps getting bigger. So in the numerator, I can take this 3 and move it outside of the limit and say that this is 3 times the limit as x approaches 3 of x. That is one of our basic laws that we can actually evaluate. Then we have the limit as x approaches 3 of 7. That's a constant. That's another one that can be evaluated using one of those limit laws. In the denominator, because we had that square, we can now move the square to the outside and the limit to the inside. So square goes on the outside, and then the limit as x approaches 3 of 16. At this point, everything that's here is now in a form where it can be evaluated using one of those last two limit laws that you saw in the previous video. So we'll call these the evaluation laws. So this will become the square root of 3 times the limit as x approaches 3. Well, what does x approach as x approaches 3? Well, I just answered that question. That's 3. For a constant, it doesn't matter what the x variable does. The value of the function does not change. Down here, as x approaches 3, x will approach 3. That's being squared. Then we have the limit as x approaches 3 of 16. Doesn't matter what x approaches. A function value approaches a constant function will always just be that constant. Next up, we'll simplify according to the order of operations. 3 times 3 is 9, plus 7 is 16. And in the denominator we have 3 squared, which is 9, plus 16, that's 25. Both of those numbers have nice square roots, and we get 4/5. Now I'd like to point out something that hopefully makes you really, really mad the first time that you see it. Take a look at the original expression that we had, this guy right here. What expression would we get if we just plugged in x equals 3? Well, that would be 3 times 3 plus 7 over 3 squared plus 16. Then you look at this and you realize that's exactly what we would have gotten. What was the point of all these limit laws? Well, the point of the limit laws is to make you understand where all of these things come from. I realize that it can be kind of frustrating to go step by step like that when you could just, plug things in. Now, with that in mind, there is a theorem regarding that, and we'll introduce that in the next video.